All right, let's take a look at a few examples so I can bring this to life and make it make sense. So we're being asked to take the function f of x equals the square root of x and the x-axis on the interval from 0 to 4 and rotate it around the y-axis. So we've already established that I'm not a good artist, but at least I can shade this region here. This is well, I'm not going to shade it. I will label it R for region. But basically what we're going to do is that we could reflect this region over here to the other side of the y-axis, and then we could take a shell or a thinly sliced section here and rotate just that thinly sliced section. And we would do that for all thinly sliced sections, on this interval or on this region R. Okay, so that's the concept of doing the volumes by shells, and we're going to take the volume of each cylindrical region that is paper thin. So we want, from the prior page, we want to take basically 2 pi for the circumference times x, since we're going around a vertical axis of revolution, times f of x dx. So again, the volume by shells for each one is 2 pi, and we'll have x f of x dx, and this is applicable to all vertical axis of revolutions, which is what we have here because we're going around the y-axis. So what we need to do though is integrate, because we're going to have to add up all of the shell volumes for every single one of these little slices that we are revolving. And the interval on which we are integrating is actually from 0 to 4. That is my x-axis interval as given. And then I need 2 pi, and I need x, and then I need f of x, and then I need dx. And I can multiply all this out. I'm going to go ahead and factor out the 2 pi out in front. And when I integrate x times rad x, I have x to the 3 halves, then goes to 5 halves. It goes to 2/5 x to the 5 halves. And then I need to integrate that on the interval from 0 to 4. So I have 2 pi times 2 over 5 times, and then 4 square rooted is 2, and 2 to the 5th is 32. So if I multiply all this out, I basically get 128 pi over 5, which is my volume by revolution. So let's do another one also with respect to the y-axis. So again, we're going to need, the circumference, or not the circumference, but the volume is going to be 2 pi and then x f of x dx. And I won't really work on showing this revolution, but I will show you that this is, the region bounded is from 1 to 3. And so this region R that we are revolving around the y-axis is actually the area between two curves. So to handle that, I need to do top curve minus bottom curve, just like we've done with other area and volume problems. So I'm going to go ahead this time and set up the factoring out of the 2 pi out in front, and I integrate from 1 to 3, and then I need x, but my f of x this time has to be top curve minus bottom curve. So my top curve is e to the x over 2, and my bottom curve is the natural log of x, and then I have dx. So then I have 2 pi. When I integrate, I have, actually, you know what? Let's just do this on the calculator, because we don't want to get into trying to integrate x times e to the x over 2 or x times ln of x. So if you throw it on your calculator, what you were going to get is the final answer of approximately 58.541, and make sure you check your work on that one. 2 curves and revolving it around the x-axis. So they're giving us y equals 1 to y equals 5, so I need to find y equals 5 here, y equals 1 here, and I need to go basically from x plus y equals 4 and x equals 3 minus ln of y, and I'm realizing that I need, this image should have been taken out a bit longer. So there we go, there's my region R. and I'm revolving it around the x-axis. So I'm going to set up 2 pi out in front, and then I have 1 to 5 being the y values that are the limits of integration, and I need y, and then I need right curve minus left curve, right minus left, just like when we do area or volume with respect to y. So I need to figure out my right curve. My right curve is this one that's curved, so it's the ln curve. So that's the 3 minus ln of y. And I'll put that in parentheses here. And then my left curve, I need to solve this for x, so it's going to be x equals 4 minus y. So I'll put in a 4 minus y in parentheses here. Don't forget those parentheses because we need to make sure this negative distributes. And then we can put this on our calculator and solve, and we're going to get approximately 95.601.